Okay, I'm going to try and go slowly through this review. Again, I apologize for not being there the other day, but I've got the flu, so I can't really do much about that. We're going to start off on this first problem trying to solve this equation, right? We have an equation here. We're going to do it by finding an LCD. So what I'll do is I'll look at all my denominators, x, 4, and 4x, and I will list those out, x, 4, and 4x. And from that, I'll create my LCD. So from LCD, I'm going to need, let's start with the numbers. Whatever number appears, let's see, 4, I'll need that. I'll need an x also. So let me see. This one has an x. I've got it in here. This one has a 4. I've got that in here. This one has a 4 and an x. I have them both here. So this should work. So I've got my LCD. And what I do is I multiply both sides of this equation by the LCD. So I take 4x, which is the same as 4x over 1. I multiply it times the left side. And then I do the same thing on the right side. So I take my 27 over 4x and multiply it times 4x over 1. Now, here's what will happen. When I distribute this through here, the 4x times 6 gives me a 24x. Over on the bottom of 1 times x gives me x. Then when I distribute this way, I get a minus 4x times 3 gives me 12x. And on the bottom, 1 times 4 gives me 4. On the right side, I could distribute this or multiply this 4 times the 27, but I'm going to do this one a little different. I'm going to cancel the common factors here, just cancel them out. And that just leaves me with the 27 on the right side. A little easier to do it that way sometimes. Okay, on the left side, the x's cancel here, which leaves me with 24. Over here on the second fraction, I can reduce 4 goes into 4 one time, 4 goes into 12 3 times. So that leaves me with a minus 3x equals 27. And now I just need to solve this for x. So what I'll do is I will subtract 24 from both sides of the equation. And they'll cancel out here. I get my negative 3x is still on the left side. On the right side, 27 take away 24 is 3. I divide both sides by negative 3 now. So divide this side by negative 3, divide this side by negative 3. And on the left side, I get x equals 1. So, I have x, and then equals on this right side negative 1. And that's it. That's my answer. Now, I'm supposed to check the answer, which I'll do just to show you it works. But on the test, I'm not going to require you to do that. So 6 over negative 1 minus 3 over 4, does that equal 27 over 4 times negative 1? So I've replaced all my x's with negative 1s. So I have negative 6 minus 3/4. Does that equal, let's see, 27 over negative 4. Well, what we need to do here is we need to get a common denominator on the left side. So I rewrite my negative 6 as negative 6 over 1. I multiply top and bottom here by 4. That's negative 24 over 4 minus 3 over 4. And if I put that together, negative 24 take away 3 is negative 27 over 4. And that is equal to this, because the negative can be on the top or the bottom. It doesn't matter. It's the same thing. So it does check. So that is number 1. Let me move on to number 2. For number 2, I'm supposed to simplify 75x to the 5th, y to the 6th. So let me take care of the variables first. We have x to the 5th. And remember, if we have a square root, that means there's a 2 out here. And the way we did this is we asked ourselves, how many times does 2 go into 5? And it goes in there 2 times with 1 left over. So that means I will pull out an x squared for the 2 times, right? X squared. And I will leave an x inside the root. So I'll just leave it in there. And then for the y to the 6th power, I say how many times does 2 go into 6? And that's 3 times. So I'll put a y cubed here, and there will be no y's left over, so there will not be a y inside the root. Then I still have the 75 in here to work with. So that's where I am now. Now what I'd like to do, excuse me for a second. I take the 75 and I try and break it down. And I try and break it down to be two numbers that multiply to be 75, where one of them is a perfect square. And remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, etc. So 75, if you look at this list here, the biggest number you get in there is 25 times 3. And that means if I take the square root of 75, it's the same as taking the square root of 25 times the square root of 3. And so the square root of 25 is 5, and then the square root of 3 I can't do anything with. So this root 75 is going to turn into a 5. That 5 will come out here with the x squared y cubed. Underneath the root, I will still have that 3 and that x that were in there. That was in there already, and I'm done. So that's number 2. Number 3. So number 3, I'm trying to solve an equation. It is a square root equation. And so we had a set of steps for this. First step was always to isolate the root. So I'm going to take the square root and try and get it to be the only thing on this side of the equation, which means I need to get rid of that negative x that's here. So I'm going to add x. Whoa. Going to add x to both sides. That leaves me with the square root of x minus 1 on the left side. On the right side, I have x minus 7. Because you can't combine those together, so just x minus 7. Now, once you've isolated the root, you square both sides of the equation. So I take the left side, I square it. Take the right side, I square it. When I square square root on the left side, the square and square root cancel. I'm left with just x minus 1. On the right side, be careful with this on the test. Squaring that means you're going to have to FOIL it. So x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x again. Negative 7 is positive 49. So collect like terms together here. Let me rewrite this here. Now we have x squared minus 14x plus 49. And what we're looking at here is a quadratic equation. So what I'd like to do is make everything equal to 0. So I would like to subtract x on both sides. So I'll put it underneath that 14x. And then I'd like to add 1 to both sides. And so we are left with the left side, everything cancels, we're left with 0. Right side is x squared minus 15x plus 50. And now you have two options. We can either factor or we can use quadratic formula. So let me see here. Hold on a second. I'm going to have to pause the video. Maybe. All right, let me get back to this. Okay, so quadratic formula or factor. I'm going to do factor. Hopefully it'll work. I'm trying to come up with two numbers that multiply to be the one in front times 50, which is 50, but add up to be the number in the middle, negative 15. So what two numbers multiply to be 50 and add up to be negative 15? So let me see, 50 and 1, that doesn't work. Actually, I usually did it in class this way. 1 and 50. 2 goes into 50 25 times. Those two can't come together and become a 15 in any way. 3 doesn't go into 54. Does not go into 55. Goes into 50 10 times. Look at that. 5 and 10 is 15. So I just got to get the signs right. If I make them both negative, then they'll multiply to be positive 50, but add up to be negative 15. So that'll be it. So what I do now is I take two sets of parentheses. I take my minus 5, my minus 10, put the x in front, and then this is where you're supposed to look at the number in front of x, which in this case was a 1, so it's not going to matter, but what you do is you put it in front of the x here and underneath the 1 here, or the 10, sorry. It doesn't change anything. All we have is x minus 5 times x minus 10. And then now set each of those factors equal to 0. So I'll do that over here. X minus 5 equals 0, and then x minus 10 equals 0. So add 5 to both sides here. Get x is 5. Add 10 to both sides there. You'll get 10. So your two potential solutions are 5 and 10. You're supposed to check those. Again, I'm not going to be real critical on the test with that. If you check them, that's just better for you. Let's see, 10, 9, let's see, that should work. If I plug in 10, it should work. But if I plug in 5, I don't believe it works. So I'll let you check that yourself. All right, let's see, number 4. All right, so for number 4, we have x to the 4th minus 13x squared plus 39 equals 0. All right. So let's see. For this problem, you're supposed to use a substitution. Okay, so this is a quadratic form. We have x squared here, and then this was twice as much as this. So because of that, I can rewrite that first one, x to the 4th, is actually x squared squared. So I'm going to make a substitution. U is going to be equal to my x squared, which I get from right there. If I do that, then I can rewrite the entire problem where my x to the 4th is actually the u being squared, then minus 13, and then the x squared we said was u, plus 39 equals 0. And now I need to solve this quadratic. Now, I don't believe the AC method's going to work here. Let's see, what are the factors of 39? 1 and 39, 2 doesn't go in there, 3 goes in there, 13 times, 4 doesn't, 5 doesn't, 6 doesn't, 7, 8, 9, 10, 11, 12. So only 3 and 13, and so that's not going to work. So I have to use quadratic formula. So what I get is u equals, quadratic formula is negative b, so that's 13, plus or minus the square root of b squared, which is 169, minus 4 times a times c, all over 2 times a. And now I need a calculator. So let me grab my calculator. Maybe. If I brought it. Where the heck is my calculator? Oh. Yeah. Thought I forgot it at school. All right. So you could do all this. What I recommend you do right now is you figure that out, but get it as a decimal, okay? So I'm going to do all this and get the decimal on my calculator. Y'all are just going to have to bear with me for a second here. Okay, so I'm going to get 2 decimals. U is, I'll just round one decimal point, 4.7, or U is 8.3. All right, so all that you'd have to do on your calculator. Now, at this point, all you have to do is go back and remember U was x squared. So just replace your u's with x squared now. X squared is 4.7. And on the other one, x squared is 8.3. And now you take the square root on both sides of this equation. And remember, always do plus or minus. Plus or minus. So I do the square root of 4.7. I get 2.16 something. I'm going to say 2.2. So x equals positive or negative 2.2. Then over here, x equals, and now I do square root of 8.3 is about 2.9. So plus or minus 2.9. And that's good enough for what I'm looking for here. All right, that's it for that. Now let's move on to number 5. Number 5, we have 2 and then x plus 4 in parentheses squared minus 7 times x plus 4 and then plus 3 equals 0. And this again is a substitution problem where you notice that you have x plus 4 here to the first power, and then right here is x plus 4 squared. Uh-oh. Okay, there we go. So what I'm going to do is I'm going to make a substitution. I'm going to let u be equal to the x plus 4. And if I do that, I can rewrite this problem as 2, and then since this is u, it'll be u squared, minus 7, and then since this is u to the first power, it's just u, plus 3 equals 0. We have a quadratic again. This one factors AC method, 6 and negative 7 here. So again, 6 comes from 2 times 3, and then negative 7 in the middle. The two numbers that do this are, oh, will this work? Negative 6, negative 1? Yeah, I think so. And so now what I do is I write 2 sets of parentheses. I put my negative 6, I put my negative 1, I put my u in front. Be careful, u not x, right? Because our variable is u. And now the all-important step where you have to look at the 2. You take that 2, you put it in front here and underneath here, or you can do it the other way around, where you put the 2 in front here and underneath here. Now I'm going to choose to do it that way because 6 divided by 2 would give us a 3, so it would be a nice number. So I should get u minus 3, 2u minus 1 equals 0. Sorry, I forgot my equal to 0. And now, once we have this, we set each one of those equal to 0. U minus 3 equals 0. The other one, 2u minus 1 equals 0. Add 3 to both sides here, you get u is 3. Add 1 to both sides, 2u is 1. Divide by 2, u is 1/2. So now, what we're going to do is go back and say, well, what was u? U was x plus 4, so I'm going to come down here and I'm going to replace my u's with x plus 4s. So I have x plus 4 equals 3. Then over here, x plus 4 equals 1/2. And solve each of these for x. So subtract 4 on both sides here. Get x is negative 1. Over here, I subtract 4 again. So 1/2 take away 4 is the same as take away 4 over 1. Get a common denominator. So I need to multiply top and bottom here by 2. So x will be equal to negative 7 over 2 because I'm subtracting, well, I'm taking 1, subtracting 8. So 1 take away 8 is negative 7, and then keep your common denominator. All right, there's your answers. Now, next problem, number 6. Number 6, just checking to make sure you solve a quadratic equation, which I've already tested several times on this exam, but it seems to never go away. Let's see if AC is going to work here. Negative 24, that's my 3 times negative 8, and then 5 here. All the factors of 24. Let's see, 1 and 24, 2 and 12. I can't get a 5 out of that. 3 and 8. Ooh, I can get a 5 out of that. Let's see, if I make that 8 here and make that negative 3, then 8 minus 3 is 5, and 8 times negative 3 is negative 24. That works. So now my 2 sets of parentheses, got 8 here, got negative 3 here, equals 0. I put my plus here because it was positive 8, x in front, x in front. Then I take my 3 here, I put it in front and underneath, or I put it in front, oops, not what I meant, or I put it in front here and underneath here. So what would work better would be for me to put it in the front of the x here and then underneath the 3, because 3 will divide into 3. So I'll choose to put my 3 here, divide by 3 here. So I'll have 3x plus 8 times just x minus 3 over 3 is 1 equals 0. Set each of these factors equal to 0. you get, over here, subtract 8 from both sides, divide by 3. Over here, just add 1. So negative 8/3 and 1. All right, moving along here. This is going a little faster than I thought. Number 7. Okay, on number 7, you're trying to solve 2x squared minus x plus 8 equals 0. And I think if you try this, it's not going to work. I made this problem so it wouldn't. So there's no way to get that to happen. You can check it for yourself. Well, I'll check it. 1 and 16, 2 and 8, 3, let's see, 4 and 4. There's no way to get negative 1 out of any of that. So our only other option is quadratic formula. So x equals negative b, which for us would be 1, plus or minus square root. B squared is negative 1 squared, which is 1, minus 4 times a, which is 2, times c, which is 8, all over 2 times a, which is 2. This is 1 plus or minus the square root of 1 minus, let's see, 4 times 2 is 8, times 8 is 64, so minus 64, all over 4. This is 1 plus or minus the square root of negative 63, all over 4. And because I have a negative underneath the square root, I can take the negative out, but I have to put an I out in front. So 1 plus or minus I root 63 all over 4. But 63 can be broken down to be 9 times 7. So square root of 63 is square root of 9 times square root of 7. Square root of 9 is 3. So I'm going to be able to turn that root 63 into a 3 root 7. So I should get equals 1 plus or minus. Now the 3 comes out, but I'm going to put the I behind it, and then square root of 7 all over 4. And I can't go any further because in order to cancel a number like here and here and here, they would all have to have a common factor, which they don't. So this is the only problem on the test that has an imaginary number as an answer. So there we go. Number 8. So now we're going to be sketching some parabolas. These are long problems. I'm going to go through them real quick though, because we just got finished with this material, so it should be somewhat fresh in your mind. Okay, so the first thing is that this is in standard form. So I know that h is negative 3, the opposite of what you see right here. K is 5, and oops, I forgot to put a is negative 5. I know this thing opens down, right, because a is negative. It's less than 0, a is negative 5. I know my vertex is automatic, it's hk, so it's negative 3, 5. A quick sketch would be negative 3, up 5, up here somewhere, and it opens down. So I know I have two x-intercepts. So I'll do those over here. My x-intercepts I get by setting the entire function, or replacing y with 0, which makes it really, so I said function, I apologize, by replacing y with 0, which makes this equation. And then I'm going to subtract 5 on both sides. And this is what you would do on your test also. Make sure you attack it this way. So that would give me negative 5 on the right side. Now divide both sides of the equation by negative 5. So that gives me x plus 3 squared equals 1. Now take the square root on both sides. Don't forget plus or minus. So square root, squared cancel. We get x plus 3 equals plus or minus 1. Subtract 3 from both sides. So you get x equals, now I had 1 and negative 1, and then I was taking away 3. So the way you do that is first you do positive 1, take away 3, that's negative 2. Then you do negative 1, take away 3, and that's negative 4. So those are your two x-intercepts. Now I will find the y-intercept. To find the y-intercept, I'm going to plug in 0 for x. So 0 goes in there, plus 3 squared plus 5. So when I plug 0 in here, 0 plus 3 is 3. 3 squared, remember I have to do that first. 3 squared is 9. So I get 5 times 9 plus 5. That's negative 45 plus 5. That's negative 40. That's my y-intercept. So I'm ready to put it all together now on a graph. Let's see. My vertex, because I'm going to have to count down negative 40, I'm going to count by 5 here. 5, 10, 15, 20, 25, 30, 35, 40. That's negative 40. That's my y-intercept. I may as well put it there now. My vertex was at negative 3, so I'm going to count here by ones. 1, 2, 3, 4, 5, 6. Let's say that's negative 6. So it's at negative 3 up 5, so that's 5. So 1, 2, 3 up 5. There's there's my vertex. I had x-intercepts of negative 2 and negative 4. Negative 3 right there. And so I'm going to draw a U through this. Remember, we have an axis of symmetry. Comes down through here. But I'll just draw my U like this. Okay, and then comes down. Oh, man. All right, good enough. There we go. Okay, so that's number 8. All this information needs to be shown. Number 9. Now, sketching a parabola in non-standard form. So since it's non-standard, I know A, B, and C. I know it's going to open down because A is negative in this problem. The vertex, I'm going to have to work to get. I use the formula H is equal to negative B over 2A, which is negative 4 over 2 times negative 2, which is negative 4 over negative 4, which is 1. And then K is what I get when I plug 1 into the original equation for x. So negative 2 times 1 squared plus 4 times 1 plus 5, which is, let's see, 1 squared is 1, so negative 2 times 1 plus 4 plus 5. This is going to be, I can't do simple math right now. 2 and 5, that's 7. Okay, so we get 7. So our vertex is the point 1, 7. A quick sketch of this means out 1 to the right 1, up 7, and from here it opens down. So I'm going to have two x-intercepts. So now I'm going to go find them. To find the x-intercepts, I have to set the y equal to 0, which leaves me with this quadratic equation. And I believe the only way to solve this would be with the quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a, which is negative 4 plus or minus the square root 16 plus, let's see, it's going to be plus because I have two negatives in here, but 8 and 5, 40, so 40 all over negative 4, so 56. Now I'm going to get my calculator out and do the rest of this, and I'll tell you what the answer is going to be. Okay, you should get two answers here. X is negative 0.8, I'll just round 2 decimals, 87. And the other one is x equals 2.87. If you want to say negative 0.9 and 2.9, that's fine. All right, now y-intercept will always be c, the value of c, if we're in non-standard form, so it's 5. And that should be enough to graph. So, oh yeah, we've got it all. Let me see how I want this graph to be. So our vertex was at 1 and then 7. So 1, 2, 3, 4, 5, 6, 7. So let's say that's 7 up here. Okay, and then we had x-intercepts of negative 0.8. So if this is negative 1, negative 0.8 is about here. And then 2.87, so here's 2. And then here's 3, so it'll be about here. We have a y-intercept of 5, 1, 2, 3, 4, 5, so that's here. We have our axis of symmetry that comes down the center here. It's got to look like a U through this thing, so I'm thinking it's looking like, not like that. It's looking more like, it's pretty wide looking parabola. I just try and make it look kind of the same on the other side. It's not great, but it's good enough. Okay, that's number 9. So there's only one more left. And I'm just going to take a quick little break, and I'll come back and finish it off. Okay, finishing this off here. Got number 10. Okay, a ball is launched straight into the air with a speed of 60 feet per second from a 200-foot building. So picture 200 feet high, ball's launched into the air, comes up, comes back down. So we're going to draw a parabola that represents that. First thing we need to do is use this equation, though. We know two things given to us in this problem, d naught and v naught. V naught is the initial speed, and it's 60 feet and feet per second, and it's positive because it's launched upward. D naught is 200 feet. That's the height. So my equation becomes d equals negative 16t squared plus 60t plus 200. So that's the answer to part A. Part B is to sketch this parabola. So since this is in non-standard form, I know A is negative 16. I know B is 60. I know C is 200. I know that this parabola opens down because A is negative. I know that the vertex I'm going to have to work for, my vertex will be, H will be negative B, negative 60 over 2 times A, which is 2 times negative 16. This is negative 60 over negative 32, which is on my calculator. 1.875. Now to get K, I'm going to have to do negative 16 times 1.875 squared plus 60 times 1.875 plus 200. So I'm just plugging that 1.875 into my equation for my equation I had up here for T. I do 1.875 and I square it on my calculator first. That comes out, this right here comes out to be negative 16. When I square that, I got 3.51563. I have plus 60. Oh, go ahead. Let me go ahead and do 60 times 1.875 is 112.5. Then I have plus 200. When I do negative 16 times 3.51563, I get negative 56.25 plus 112.5 plus 200. So adding all those together, what we got here? Somewhere around 256.25. Okay, and then now I need to know my x-intercepts. I know it opens down. I know I have x-intercepts already. So to find those, I take my equation there. I set my d equal to 0. So I try and solve this. I use quadratic formula to get t equals negative b plus or minus the square root of b squared, which is 3600, minus 4 times a times c all over 2 times a. And get that and work that out. So again, I'm going to just leave that to you. I'm going to go ahead and just do this on my calculator. Okay, I'm getting two answers, negative 2.13 and 5.88. I've rounded those, but those are the x-intercepts. My y-intercept is c, which was 200. And so now I'm going to put them all on a graph and draw my picture. And because this is an object that's going up into the air, I know I'm only going to have this side of it. 200 is my y-intercept. At 1.875, so here's 1, here's 2. At about 1.875, I get to my maximum. Up there it's 256.25. And then I have an x-intercept at 5. So 4, 3, 4, 5, 5.888. So here's 6. So 5.88 is about right there. And I know there's another x-intercept back here, but I don't plot that because this is an object, right? So there's no negative time. So it's going to look like this. Like that. That was the maximum right there. So that's part B. Part C, I can answer the rest real quick now. What's the maximum height of the ball? Well, it was 256.25 feet. How long did it take the ball to hit the ground? That was my x-intercept, 5.88 seconds. And that is it. I really hope that helps out. Again, I'm sorry I missed class the other day, but it is what it is. I'll see you all next week.